What is the triangle law for adding vectors? Given two vectors u and v, what is the vector sum resulting from adding u and v? In order to understand better the concept of adding vectors, we need to know what it is that we are adding exactly. To understand the concept of addition, let us look at these two balls. Each has a defined weight and a defined volume. I could, for example, add the weights of the two balls to determine the total weight. However, could I add the weight of the first to the volume of the second? Not really, because right here I'm not adding similar quantities. Going back to our vectors, by adding these two vectors, what are we really adding? We know that a vector is characterized by its magnitude and its direction, which in total forms a displacement from one point to another. So what we are really adding here are the displacements. Starting from any point, I move along the displacement defined by vector u. Then I add to it the displacement defined by vector v. So I first moved from a to b along vector u, then from b to c along vector v. Then in total, I would have displaced from a to c, which gives the resulting vector u plus v. Then the sum of vectors AB and BC is in fact vector AC, obtained by completing the triangle formed by A, B, and C, where B, being at the extremity of the first and at the origin of the second, was just a mean to move from A to C. Let us take it further by adding three vectors, U, V, and W. Again, starting from any point, I move along the displacement u, then along the displacement v, then along the displacement w. Naming the points a, b, c, and d, the vector sum resulting from adding u, v, and w would be vector ad. Let us see why. Along the displacement u, I moved from a to b. Then along the displacement v, I moved from b to c, which yields to a total displacement from A to C, which is vector AC according to the triangle law. Adding to that the displacement from C to D gives a total displacement from A to D, which is vector AD according to the triangle law again. Therefore, the triangle law can be applied consecutively to add any given number of vectors. But what about the magnitude of the vector sum? If the vector sum AC is the total displacement from A to C, then the magnitude of the vector defined by distance AC is in fact the total distance traveled by that displacement from A to C. We know that in triangle ABC, distance AC is smaller than the sum of the other two sides. Then the magnitude of vector u plus vector v is smaller or equal to the magnitude of vector u plus the magnitude of vector v. But when would it be equal? And when would it be strictly smaller? According to the triangle law, vector AB plus vector BC is equals to vector AC. In the case where A, B, and C are collinear with point B between A and C, going from A to B, then from B to C to give a total displacement from A to C actually gives distance AC exactly equal to the sum of distance AB and distance BC. Well, if B is outside segment AC, then moving from A to B, then going back from B to C gives a displacement from A to C with distance AC smaller than the sum of distance AB and distance BC. Well, if points ABC are not collinear, then moving from A to B, then from B to C would actually form a triangle, and the resulting sum vector AC would have a magnitude smaller than the sum of distance AB and distance BC.